In this video, we'll be looking at Introduction to Set. Before I continue, I would like you to subscribe to this YouTube channel and do not forget to hit the notification bell to get notified for upcoming videos. I believe we are all familiar with the word set, even from our everyday life. The word set occurs in our daily activities in various forms, from the home to school and in our dealing with one another. For example, we talk of sets of cutleries. We also talk about sets when we're talking about a football team, a collection of books in a public library, a collection of tools in a carpentry shop, and so on and so forth. The most common among all also are familiar with mathematical sets, which is a collection of mathematical instruments used for construction or for drawing. So we can therefore say that set is a group of objects that have unique characteristics that differentiate them from one another. Basically, we can say set is any clearly defined collection of things, objects, or numbers. Sets are usually represented in capital letter. For example, let's say we have a set A. So we use capital letter to differentiate to define a set. It can be any letter of your choice. Set A, set B, set C, set D, set E, and so on and so forth. So inside a set also have what we call members. A set also have what we call members. And when we're talking about members of a set, we're talking about the elements that are contained in a set. Just as in a football team we have the members, so also is a set. Every set has its element. It has its element. Let's say this set A now has element. It can be numbers, it can be letters, it can be in word form, in whatsoever form. So let's say we have set A has element A, B, 1, 2. Let's say it just has this four sets. So A, B, 1 and 2 are the members of set A. So just like I've written here, the members of a particular set are always written in curly braces. So these are the curly braces. We have this and this. These are the curly braces. They are always written with curly braces. And if you are writing the elements of a particular set, maybe in word form or in alphabet form, it has to be in small letters. It has to be in small letters, and each of the elements are to be separated by a comma. Also, let's say we have another set D and it's in word form. Is a set that's a collection of okay, let's say cutleries. So in cutleries we have spoon, we have the fork, and we also have knife. So you separate the elements of a set with comma just to show that these words, these elements are different. But if you don't use a comma to separate them, you're talking about one thing. For example, if I just write spoon, fork, knife without separating it with a comma, that simply means I'm defining only one thing. They are not different. So when you use comma to separate them, it means that there are different elements in that particular set. Now let's look at ways of describing set. How can you describe set? Number one, we have word description. Ways of describing a set. So number one, we have is a situation whereby you are describing a set, you are not straight to the point. You did not define exactly what you're talking about. You use words to describe it. For instance, let's say we have set S, and set S talking about the student in 100 level. So this is a word description of a set. You've described it in words. You do not define it or you say boys or this. No, it's talking about the student in 100 level, whether they're in SPS, physical sciences or life sciences, so long they're in 100 level. S is a set of them. So this is number one way of describing a set. Another way of describing a set is listing. Yes, by listing a set of numbers. So listing a set of numbers. This one we are very much familiar with it. You are giving the numbers and they are listing, they are direct. Let's say we have a set of nature of just numbers, any numbers. N is representing a set of numbers. So we have 1, 3, 5, 7, 9, dot 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 dot, meaning they continue. So this is what a set of numbers. You are listing, you are being specific. You are being specific. And the fact that it's a set of numbers does not, it does not only applies to number. Like the first example I gave here on set D. Set D is also an example of listing. I listed here in set D, I listed what the set of cutleries. I'm being specific. Assuming I just said D equal to in curly braces set of cutleries, that's under word description. I'm describing it. But now I said spoon, fork and knife. So whosoever sees this will be like, oh, these are cutleries. So this is said this is also under what? Listing. Then the third one, we also have stating a rule. Yes, stating a rule. That's the third one. By stating a rule. Now in this stating a rule, you are giving a rule on how to get the particular set. For instance, let's say we have you said, okay, a set of numbers divisible by 3. A set of numbers divisible by 3. So let's say B is equal to, it's not really compulsory to put the set of number. You can just say B equal to numbers divisible by 3. So if we are to further simplify this, when we are looking at numbers divisible by 3, we have 3, 6, 9, 12, and so on. They are much. We have so many of them. Now this is a rule. So the rule can be numerous. It can be a set of number of even numbers, set of odd numbers, and so on and so forth. So this is another description of a rule. Let's say we have B, a set B, 9 less than or equal to x less than or equal to 13. This is also a under rule. Yes, it's under rule description of a set. Now is this, now they are only trying to tell us that this particular set X or a set B is greater than or equal to 9 and is less than or equal to 13. So when you are trying to list this, we have, since the equal to there is there, you start from 9, then you go to 10, 11, 12, then you check what we have here, here also is having equal to, that means these two are inclusive. So the equality sign there is trying to say that the two numbers are inclusive. Yes, they can be found in that particular set. But assuming there is no equal to, let's say we have another set C, and they said 10 less than x less than 15. Now this is trying to say that 10 and 13 and 15 are not inclusive. So x is greater than 10, so we have 11, 12, 13, and x is less than 15. That means we are stopping at 14. So this is the answer to this given rule. This is also the answer to this given rule. So that's for rule. The last way of describing a set is by using diagrams. Number 4, using diagrams. You can use diagrams to represent sets, and this is where Venn diagrams comes in. You drawing circles and enclosing members within them. So that's all for ways of describing sets here. Drawing circles. And enclosing members within them. So this is all for describing of a set. As we move further, we are going to look at Venn diagram. So now we'll be moving to definition of terms. There are certain terms that we need to understand when we are talking about set theory. This is actually some of the basic things, because without understanding these terms, we cannot be able to solve or answer questions concerning set theory. So the first thing I'll also look at is number one thing I'll want us is what we call subsets. Subsets and supersets. So this is under definition of terms. So we have subsets and supersets. Now let's assume we have, so let's say we have two sets A and B. We have two sets, set A and set B. Now if set A consists of some or all elements of set B, then set A is said to be a subset of B, and it is denoted by this. This symbol is the symbol of subset. So if we say A is a subset of B, that's if A contains some or all the elements of B. Now for instance, let me give an instance. For instance, if we have set A to be equal to 1, 2, 3, and 4, and set B to be equal to 1, 2, 3, 4, 5, and so on. Now we can say that A is a subset of B, because if you look at the elements of A, you can find them in B. So it's just like it's inside. A practical example is a baby in his mother's womb. So using a diagram, we can represent this by this. Let's say this is set B and this is set A. So set A is inside set B. This is a diagrammatic explanation of subsets. Now supersets. When we are talking about supersets, When we are talking about superset, here we can say B is a superset because it is in B that A finds itself. So B here is the superset of what? Of A. So this is one of the terms I want us to get. The next term I want us to understand is what we call cardinality. Cardinality. And when we are talking about cardinality of a set, we are talking about the total number of elements found in the set. Total number of elements Now take note, I did not say sum of elements, I said total number of elements, and it is usually represented by this. Let's say we are looking for the cardinality of a set A, so we just do n of A. If it is the cardinality of set B we are looking for, we'll do n of B, and so on and so forth. But now you ask yourself, what if a particular set does not have an element? Now this is where an empty set comes in. For example, let's say this set A has no element in it. We can call this an empty set or a null set. So now, what will now be the cardinality of this set? The cardinality of this set, because nothing is inside, it will be what? 0. As simple as it is. The third term I would like us to look at is equality sets. Equality sets. Now, two sets are said to be equal if they have the same element, irrespective of the position. If they have same elements, irrespective of position. For instance, let's say we have a set A equal to A, B, C, D, and we have set B to be equal to B, C, D, A, and we have set C to be equal to C, D, B, A, and we have set D to be equal to D, C, A, B. Now, we can say that A is equal to B, is equal to C, and equal to D. Why? The reason is because if you check each of the elements, they all have A, B, C, D. They are the same, irrespective of the positions. The A, the B, and the C, and also the D, must not be in the same position. Like set A now, A is the first element there, but B, C, and D is different. So, but so long the elements are the same, not minding their position, we call it an equality, or you can say equal set. Then the fourth term, we have equivalent set. Equivalent set. When we are talking about equivalent sets, two sets are said to be equivalent if there is one-to-one correspondence between the elements in the two sets. If there is a one-to-one correspondence, between the elements in two or more given sets, we call those sets an equivalent set. For instance, let's say we have a set P to be a set of let's say gender boy, girl, okay, and we have a set Q to be a set of number 1 and 2. Now, what this equivalent set is trying to say, let me explain it in a simpler term. If the elements in that two given sets have the same cardinality, have the same numbers, we call them equivalent sets. Now, set P has two elements, which is what? Boy and girl. Set Q has two elements, which is what? Q and 1 and 2. So we can say that set P is equivalent to set Q. If they both have 3 elements each, we can say that set P is equivalent to what? Set Q. The fifth term I would like us to have knowledge about is what we call finite and infinite sets. Finite and infinite. Finite and infinite sets. When we are talking about finite and infinite sets, we are talking about, let me start with the finite set. It has an end. Something that is finite has an end, but something that is infinite does not have an end. For example, if we are saying set of all even numbers, if we just say, okay, set R is set of all even numbers. This is an example of infinite set because we are not asked where to stop. You keep on listing and listing and listing. You get to thousands, tens of thousands, hundreds of thousands, millions, tens of billions, and you continue like that. So this is an example of infinite set. But finite set has an end. Okay, let's say set of first 10 even numbers. Let's say set S is first 10 even numbers. So you already have it in mind that, okay, when I'm starting to list this, let's do this. We have 2, 4, 6, 8, 10. We have listed this 1, 2, 3, 4, 5. Okay, 10, 12, 14, 16, 18. How many now? 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have 20. So this is the first 10 even numbers we have. Now it has an end. That's an example of what? Finite set. The sixth term I would like us to look at is what we call unit set. And when we are talking about unit set, we are talking about a set that contains only one element. Only one element. For example, let's say example set A. So set A is what? A unit set, as simple as that. Then the seventh term is what we call universal set. The universal set is talking about is a set that contains all the elements that can be used to solve the problem under consideration. It is usually denoted as this. We use this symbol or this symbol. So this is a universal set. Now universal set, from the word universal, it contains all the elements that you use to solve a given question. By the time we move to operation on the set, you will have a clearer and a better understanding of what the universal set is. Now the eighth term is power set, which is the last term I want us to look at. Power set. Now what does the power set entail? The power set is a collection of all the subsets of a set S, or it does not have to be S, of a given set. The subset of a particular set is called the power set. Now let's look at an example. We have set N to be 1 and 2. Now if you are asked to find the power set of this set, the power set will be, you first start with the null set, which is the empty set. So we have something like this. This is the first one, and we also, because every set must first have an empty set before you fill in something. It must first be empty before you fill in something. So we have the empty set, then we also have we have 1. 1 is one of the elements. We have 2. After this, you now pick the remaining 2. So the power set of this, there are just 4 elements: the null set, element 1, element 2, and the 2. So there is a general formula for getting the number of elements in a power set. You just do 2 raised to power n. N here is standing for the number of elements. N equal to number of elements. So this example above that I did, it has just 2 elements. So when you do 2 raised to power 2, 2 power 2, we have it to be 4. So that's why we have just 4 elements. If it is 3 elements, you do 2 raised to power 3, and 2 raised to power 3 will be given with what? 8. So it will be 8 elements in the power set. So thank you for watching this YouTube video. Do not forget to subscribe to this YouTube channel and hit the notification bell to get updated for upcoming videos.